made of metal. And here you have a lens. The front one is lens. So light when it goes, it will be focused on the sensor. The light falling will be focused by the lens and fall on the sensor. Depending upon amount of light intensity, correct? I said 0 to 100 lumens, light is changing, intensity changing. Then the output it may produce 0 to 100 millivolts, for example. It will produce, the photodiode will produce 0 to 100 millivolts. Generally, it produces current that will be amply converted to voltage. Right? Basically, it will be 0 to 100 milliamps or something. Current is produced that can convert into voltage. For understanding purpose, we always talk in this one. This is how it works. Symbolically, the photodiode will be shown like this. This is a diode symbol, correct? Conventionally, this is diode symbol. This is called anode. This is called as cathode. This is a diode conventional. Only thing is, additionally, you show that this is light. This symbolically represent like this. Okay. Similarly, phototransistor. Transistor is three-terminal device. It has emitter, base, and collector. This is symbol for normal transistor will be shown like this. This is collector, emitter, base. This is what is shown. But in case of phototransistor, this is phototransistor. See that this base, the base line is not there. Correct? Here, this shows light. If light falls on base, automatically a current will flow. We call it IC. Collector current will flow. We'll see how it is. So it is a three-terminal device, but base pin will not be there. Instead, again you can see the opening. Similar to photodiode, there's a lens, there's an opening. This is the body. Correct? These are three wires or terminal called emitter, base, collector. And this is lens. If light falls on through lens, it is focused on the transistor which is inside, and it produces current IC, current flowing from collector to emitter. We'll see how it works. So this is the cross-section view of the actual semiconductor material. You can see that it is a NPN type transistor. This is called as N-type material. Again, on which they doped P-type material. Again, they doped N-type material. This small N-type is called emitter. The bigger, this one is called a base. And the last N-type called collector. Now, normally you will apply a voltage between these two. We call VCC, plus and minus. Plus is connected to collector, minus connected to from a DC voltage source. In case of normal transfer, base also you have to give you a voltage. Plus minus, that you need, this is called VBB. This is called a VCC. Correct? Two power supply needed. But in case of phototransistor, you don't need this. Without that, if we shine light on it through this, the base will start conducting. It conducts automatically. Current will flow from this IC. We'll see how it works. So this is basic structure of a symbol, how it looks physically. This is internal architecture. This is the physical photodiode and the symbolic representative what is under. Next one is called LDR, light dependent resistor, LDR. So it may look physically, it may look like this. This is a physical photograph. I took it for internet. In which this is the body, correct? Actual LDR sensor is nothing but light dependent sensor made of cadmium sulfide material. You can see that a serpentine, brown color is this one. The bottom one, correct? This is called a base, which is non-conducting material. Electrically non-conducting material, you can see that a circular ring type material on which the cadmium sulfide material is deposited in a serpentine fashion, loop fashion. Right? This is what the LDR sensor. Right? Now, and this is a body. Again, there's a lens. Right? Here the top is front lens. And if light falls on it and hits the LDR sensor, its resistance changes. Its resistance changes like this. When light is 0, this is light intensity 0 to 100 lumens in x-axis. Y-axis is nothing but resistance. I can say that this will be maximum. This may be 10 megohm, 10 into 10 power 6 ohms. As light increases, you can see the resistance is decreasing. For 100 lumens, the resistance may come around 1000 ohms. Okay, so you can see the decreasing. This is the change in resistance depending on light intensity. So if I measure the resistance by using connecting these two terminals to a ohm meter, I can say what is light falling it. I can calibrate, I can use a light meter. This is called as LDR sensor. It can be used for many purposes that you can read it this way. Okay, now let us see what a how it works. Here I told you overall information. We are seeing little more deeper. Okay, the photodiode working. We know that it is a PN junction diode. Photodiode called as a PN junction diode. One side you have P-type material. This is junction. You could now note that this is called a junction. This side is P-type material. This type is N-type material. There's a junction formed. One junction is formed. We know that in P and P-type material, which is shown left side of this one, I can see the blue color circle. The blue color circle represents holes, which is nothing but positive charged particles. In P-type material, consists of positively charged material called as holes. It filled with. Similarly, the N-type material, which is shown with the red color circle, they are electrons, which is negatively charged particles. So N-type material has electrons, P-type material have holes. Holes are positive charge. Now, if we form a junction, what happens in this region? The electrons will be attracted here, one side of the P material. Similarly, the holes will be attracted to this side and it becomes depletion region. Depletion region means non-conducting region. That means the charged particles from the region is removed, but still there are few. Okay, you see, first thing is it happens like this. Okay, you forgot the remaining part. So only this carriers are moved to one end. So that means this area is non-conducting, which is called depletion region. That means the holes from this side, these are holes and these are electrons, cannot move from one side to another. You know that opposite charge always attracts. Holes will attract electron, electron will attract. So they will join, they combine, become neutral. Charge is removed. But the problem is once junction is formed, you know that the neutral region, this region prevents the holes moving this side. Right? This is plus plus. You can say that plus plus. They wanted to go to this side. Similarly, the electron want to go this side. The holes want to go to the because they are attracted. But this fellow prevents. Here, the charge particle combine, become a neutral region called depletion region. These holes and the electron cannot pass through this region. Now, if I wanted to, we know that the current is nothing but flow of electrons. So if the electrons are stopped, because the electron want to go from here, it is not allowed. What I do, I connect external voltage, which is called a bias voltage. I call it VD, diode voltage. What I did, I took a battery, right? This is my battery. I connected the positive terminal battery. Okay, sorry, small, this one, correction. So this should be positive. Sorry, very sorry. While drawing, I made a mistake. So this should be negative. This should be positive. Battery positive should be connected to anode. Okay. This one should be connected to cathode. Okay. So if you connect like this, what will happen is the okay. Little more. This one, very sorry. This we are talking about photodiode. The connection is correct. The figure is correct. There is no doubt. This is for, I told you, the reverse bias. Now, because while making PPT, I made correctly only. I not made mistake. But normally, diode will be connected like this to your power supply. Okay, battery plus minus. I supply voltage VD. This is anode. This is cathode. This is called as forward biasing. Forward biasing. Here, what I drawn is correct only. This was this one. Positive forward biasing means the battery positive or power supply positive will be connected to anode. Power supply negative will be connected to cathode. Then a current from battery positive goes inside the anode, comes out, circuit closes. When the VD is greater than, when VD is greater than 0.7 volts, then current from positive of the battery goes inside the anode. Current flow. This is called ID. They call forward bias condition. Okay. In case of photodiode, what I do is I connect the battery in opposite direction. Cathode is connected to positive terminal, anode is connected to negative terminal. So automatically the photodiode will not conduct. But what now in photodiode, if I allow light to fall on the base junction, this area, this light, automatically what happens is it creates electrons and light creates electrons and holes in the base region. Okay, those electrons this one will be attracted appropriately. Okay, so you can see that from the p-type material, the holes will be attracted to the negative of the battery, reverse bias battery. Electrons will be attracted by the positive of the battery in reverse bias condition. Reverse bias means what it is? I will connect N, that is cathode, to positive of the battery and anode to negative of the battery. When light is not there, the diode will not conduct the current, this current will not flow. But if light falls on it, it creates the additional electron, photo electrons. Correct? That is what these are called photo electrons. They are created because light. Number of photo electrons created depends on light intensity. If more light is there, with more electrons that is attracted, then a current flows. The red color arrow mark say electrons are moving from like this. So that means conventional current flows through this, correct? So this is called as photo current or photo electrons. Okay, this is how it works. Now, in photodiode, the equivalent circuit shown here, you can see here, the equivalent circuit is nothing but it has a current source which produces a current we call IP. IP is nothing but photon current. If no light into 0 lumens, photon current IPH equal to 0. Okay. If this is 1 lumen, then IPH may be 1 milliamps, for example. If 2 lumens, it will produce 2 milliamps. If I produce 10 lumen light hits on the base, it will produce 10 milliamps current. For example, I'm saying it can microamps, nanoamps, picoamps, or milliamps, depending on type of this one. So it produces. That is what is shown here. And now that current goes out, and some amount of current goes inside the ID diode current. Remaining current goes to load. Correct? This is called a load resistor connected. So the current goes like this. And of course, the diode also has some capacitance. It has internal shunt resistance. It has some series resistance. All this thing you don't worry. This I am not going to ask you. Okay, this is only for understanding purpose. It has diode has a capacitance. It has internal resistance, and we call dynamic resistance. Last time I told this is load resistance, external resistance which I am connecting. But main thing is this: if light falls on it, reverse bias diode produces a current which flows through the circuit. That is called a photon current, IPH. Okay, so what is the current amount of produced? That can be called as there are two type of current. What is called photon IPH, other one is called ID. ID means dark current. That means if no light is falling, still there will be a small amount of current going. That means they are called dark current in reverse bias diode. How much it be, that can be calculated using this formula. Dark current when low light is shining, theoretically dark current should be 0 amps. But actual diode doesn't happen. There will be some amount of current, nanoamps current, picoamps current, or microamps current, maybe 1 or 2 microamps will go, that you cannot avoid. That you can calculate using what's called dark current. That means even without light, there is a minor current that can, but it will be negligible. That can be calculated using this formula. The formula what it says, dark current equal to I sat multiplied by, there's a multiplication signal, multiplied by e power Q into VD divided by KBT minus 1. Where I sat, the saturation current of the diode that is given by the photo diode manufacturer. In this equation, T is as temperature of the diode. The surrounding of what is temperature measured in Kelvin. Then Q is called as charge of individual electron. That we know 1.6 into 10 power minus 19 coulombs. Okay, very small quantity. KB is called a Boltzmann constant. It is called as a Boltzmann constant. That is applied KB is 1.3 to 10 power minus 23 joules per Kelvin. VD is the applied voltage, reverse bias voltage, what you are applying. You may apply 1 volt to 2 volts, 3 volts, or 5 volts, whatever may be, depending upon the diode maker, what is maximum reverse voltage you can apply. Correct? There are diodes which can work even 100 volt above also. Special purpose that you have to do. That's how the diode works. If light falls on it, yeah, current flows. That can be calculated using this formula. Dark current means when there's no light, what is the current? When the light falls on, accordingly the current increases. So now if light falls on it, this is what the current we are going to get. IP or IPH, you can say. IPH is nothing but photon current. As the light intensity increases, current will be generated additional. Correct? This is a dark current part. This is the photon. As lumens increases, that will be there. This is called total current. So how will you amplify the signal coming from photodiode? So you need an amplifier, because the change of current produced by the photodiode will be very small. This current I shunt or I photon will be very small. That should be amplified. For that, you need to use an amplifier. This is typical. So this is my photodiode. This is a light falling on it. If light falls on it, there's a current flowing I shunt, which consists of IP or photon IPH. So that voltage will be amplified. The amplifier output voltage will come. I can connect two ways photodiode. One is called, this is called reverse bias photodiode. Otherwise, without the power supply, I can directly connect photodiode to a op-amp. This is called as op-amp, which is nothing but an amplifier circuit. It will amplify the current produced by the photodiode. IPH will be also we call I shunt current. That will be amplified by this. So how much voltage will come? That can be calculated using this formula. This amplifier has a AD diode, that is called the op-amp has amplification factor. I call AD. The amplification factor multiplied by the IHS, which is proportional to light. More light, more IHS, multiplied by this RF. Sorry, this should be RF. Okay, RF is nothing but feedback resistor. So this is how it works. V0 can be written as minus RF into IHS. And this is output. For this output is this. This is called as reverse bias photodiode. This is directly connected. Without reverse bias also you can use photodiode. In this case, you should connect to op-amp like this. If you connect like this, the output of V0 is proportional to IHS or photodiode. That depends on light intensity. Correct? This current is going to depend upon light intensity. If light varies, the output voltage changes. This is the photodiode can be used. Any doubt in this? Okay. If it's not there, then we'll go to phototransistor. Okay. Phototransistor, we know that symbolically the transistor is represented like this. Generally, transistor is represented like this. Right? So this is collector, this is emitter, this is base, this is a 3-terminal device. You need to give power supply. Okay. One small correction, and let me do that. I have my regular transistor, which has emitter terminal, so with an arrow. Collector is this. This is base. Then I need to connect to a additional resistor and power supply. Then only transistor will work. We are going to see about transistor when we talk about amplifiers. Maybe in another after 2 classes or something. And this is connected to ground. This resistor is called RC. This is plus minus called VCC, collector voltage. And again, you need to connect one more power supply like this. But to make a transistor work, you need to have 2 power supplies called base voltage, VBB, base supply or base bias voltage, VCC called collector voltage. So then I have RB, base resistance. So now, since I am applying voltage to base, there will be a current flow, IB. This current is IB equal to VBB minus VBE divided by RB. RB is resistance. Similarly, the current going to collector from this power supply called IC, IC equal to VCC minus VCE divided by RC, no doubt. Okay. So the transistor, this is called a regular transistor. It has collector, emitter and base, for which I need to supply 2 power supply. One is base voltage, other one is collector voltage. Again, we should know that VB should be smaller than VCC. VBB should be smaller than VCC. How much? At least 1.5 volts. 1.2 to 1.5 volts. It should be lesser. That means if my VB is 5 volts, VCC should 6.5 volts minimum. Higher than only transistor will conduct. Supplying this VCC and VBB to through the resistor is called as biasing the transistor. Biasing transistor. This is for conventional transistor. What I am done is conventional transistor. Please note that. Then, if I give this voltage, we know that there's a current going in the base, which is called input current IB. IC is called output. Okay. There's a relation for this circuit. There's a relation. Take down. In a conventional transistor, IC, collector current. Note down. Collector current. IC equal to beta into IB, where beta is called current gain of the transistor. If you buy a transistor, you need to see 5 important parameters. One thing, note down. First one is what you call as VCC. That is called collector supply voltage. Collector supply voltage. And how much for a given transistor, the manufacturer will say, you can give 3 volts. I said minimum is 0 volts, maximum I talk VCC max. Maximum 3 volts. Some transistors say 5 volts. Somebody says 10. Somebody says 100 volts. Some transistor. Some transistor maybe even 1000 volts. They call high power transistor, high voltage transistor. Okay. So that is first parameter. What is the maximum voltage you can apply? That means you can apply 0 volts to collector. This voltage can be 0 volts, 1 volt, 2 volts. If I say 10 volts is the maximum, I can apply 0 to 10 volts only. Okay. That is one thing. VCC can vary. The second parameter is VBB. Again, VBB also 0 to 5 volts, 0 to 10 volts, or 0 to 50 volts. Different transistor manufacturer talks about that. Okay. Please note that the VBB for a given transistor should be always greater than VCC. If I say I have a transistor, VBB equal to 10 volts maximum, I'm talking 0 to 10 volts you can apply. VCC will be automatically greater than 0 to 12 volts. These are second parameter. Third parameter is called IC max. What is the maximum current can flow? Collector current. This is called collector current. This is called collector voltage. VCC is called collector voltage. I already told you, correct? VC is collector voltage. VB is called base voltage. IC is called collector current. What is IC max? They say 100 milliamps. Minimum, please note that wherever we say current voltage, minimum is 0. That is well known. Don't worry about it. Maximum. IC max is 100 milliamps. Some transistors can work up to 1000 milliamps, 1 amps. Correct? Some transistors can go up to 100 amps also. There are power transistors like 500 volts, 1000 volts, 100 amps, 50 amps current. They can very bulky and they can dissipate a lot of current. They are called available, but they are very special purpose. IC max. Similarly, IB max, that is called base current. How much maximum base current can flow? That is called IB max. Can be 0 to, for example, 100 milliamps, or 0 to 50 to 10 milliamps, or 0 to 100 microamps. Can be. Please see that IB will be always much lesser than IC max, because that depends on the. Then this is the fourth parameter. The fifth parameter is beta. What is the current gain of the transistor? That is very important. They call current gain. That decides why. We already told you transistor is called as an amplifier. What it is going to amplify? It is going to amplify current. Transistor will amplify current. Current amplification is done by transistor. Okay. What current? IB will be amplified. How much? Beta times. Then what happens? This much current is produced by IC. That's what I shown here. Shall I clear this? You have noted important points?
Okay. Sir, 2 minutes, sir.
Yeah. So important specification when you select a transistor for, if you want to build a transistor amplifier, you need to know what is the VCC. That you will decide what is maximum voltage you are going to apply to your transistor. What is the VBB max? What is the IC max? What is the IB max? And what is the beta? Last one is, that is beta is the this one. Last one is power dissipated, P transistor. how many watts? Say 500 milliwatts or 100 watts or 1 kilowatt or 100 kilowatts. Power transistor. These are power transistor. These are small transistor. So maximum supply voltage, collector voltage, maximum base voltage, maximum collector current, maximum base current, correct? Then maximum power dissipated by transistor and also beta. These 5 parameters should note down. Let me clear. No issues. So
Yes, sir. Yes, sir. Just finished.
okay. Now again, when in the conventional transistor, let me draw quickly so that you will. This is power supply. This is RC plus minus VCC. That is a collector voltage. This is emitter. This is the NPN transistor. How will you know the NPN transistor? Because transistor can generally shown like this. Correct? This is, you can see that this is collector. This is emitter. Emitter, you see one arrow coming out. If in a transistor, if the emitter arrow is going in, it is called as PNP transistor. This is emitter, collector, this is base terminal. If arrow is coming out, it is called as NPN transistor. This is base. This is PNP transistor. Correct? That means it has a P layer, N layer, P layer. They are called PNP transistor. N layer followed by P layer followed by a again N layer. It is called NPN. Symbolically, it is represented like this. That's one thing. Next thing is anyway, I will be explaining, but here itself I explain some of the things so that it will be easy for you to understand. Now, base also you have a resistor RB, which limits the base current. How much base this one? There's a VBB. VBB plus minus, correct? VCC plus minus. The RC. Okay. Now, this current is called as IB. This current is called as IC because power current from the battery goes through the load. This RC is called load resistor, collector resistors, enter into the collector terminal, comes out and completes. This is called the emitter through set. Similarly, from this current, from base, you apply a voltage. From the plus of this one, the current enters to the base terminal, comes out to a, this is emitter terminal, correct? Comes out, the circuit is called, correct? There are two current, one is IB, other one is IC. Both are related. Note down the formula. Because in the example, in the exam, you may ask, you have a conventional transistor there is beta. IC collector current equal to beta times IB. IB equal to what is IB? This IB equal to, note down, IB equal to VBB divided by RB, where RB is this resistance. Okay. For example, the manufacturer says that maximum IB max, correct? IB max, he says that 100 milliamps. IB max equal to 100 milliamps. And he says that this is IB max. VB max, he says that 5 volts. That is maximum voltage. 0 to 5 volts you apply. When I vary current 0 to 5 volts, the current going to base will be 0 to 100 milliamps. In that case, I can calculate what is RB value. Because this resistor you are going to calculate. RB equal to VBB max divided by IB max. Who is going to give this? The data is available to data sheet. Already I told you the VB max is 5 volts. Correct? Divided by IB max is 100 milliamps. 100 into 10 power minus 3 is correct RB resistance, which is nothing but 5 into 10 power 3. This goes up 10 power 3 divided by 100. 2 zeros gone, here gone. That means 50. So RB can be 50 ohms. RB equal to 50 ohms. Because the manufacturer transistor, particular transistor, he has given VBB max and IB max. From that, I can find out what is this resistance value. So from the VBB plus terminal, you have to connect a resistance of 50 ohms. One end, other end is connected to base of transistor. Similarly, what is RC? RC equal to VCC max divided by IC max. Who is going to give? The transistor manufacturer. For example, VCC max, they said it is 12 volts. They say IC max equal to say 2 amps. What is RC? RC equal to 12 divided by 2 is going to be 6 ohms. That means this resistance can be 6 ohms. Now you are designed the circuit, amplifier circuit. Now, if I vary the VBB, IB will vary according to the formula. Already we know that IB equal to VBB divided by RB. Correct? If I vary the this one 0 to 5 volts, this IB will vary 0 to 100 milliamps. Okay? Then what will happen? IC, what is formula here? IC equal to beta times. I said that this gain of the transistor beta equal to 100. Beta is given at 100. What is IC now? If I give, say, for example, 2.5 volts, VBB is 2.5 volts. What is IB? 2.5 divided by, already found the resistance value. What is the resistance RB value you found? 50 ohms. Correct? So, from this, you can find out the current. That multiplied by this current multiplied by beta is going to be your IC. You can calculate. These are the regular transistor works. Okay. Now, these formulas are very important. Yes, please.
Sir, already under 2 minutes are there, sir.
Oh, time up. Oh, today very fast. Okay. Then this formula. So take these formulas to we can compute how much of power, voltage, current is produced in a transistor. Since the transistor is going to amplify the base current beta times, it is called as amplifier. Because of the reason only it is called as amplifier, conventional amplifier. In photo transistor, instead of supplying IB by supplying a base current, correct? I apply light. If I apply light, IB is created. IB is proportional to, already I say IB is proportional to light intensity. If I shine more light on base, more base current goes. Automatically, more base current, more collector is. So the IB is proportional to light intensity. If IB varies due to change in light, the IC also varies. These are the photo transistor works. I stop here. We'll see tomorrow. Okay. Thank you. See you.
Thank you.
Thank you, sir.
Okay.
Thank you, sir.
Okay. Take care.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Give your attendance before leaving. That is important.